to our friends. I'll tweet the link and you can rebroadcast it if you so desire.
I even did Instagram Live to promote.
No way. Oh, okay. Awesome.
Yeah.
Awesome. All right. I think we are live. Let me check on the interwebs. Is there anybody out there that can see us? I've got. Currently, I don't see it, but we're waiting. Let's see here. 27 thumbs up. There's one person watching it so far. Let's give it a second. Sometimes it takes a little while. We're used to instantaneous.
It's my aunt. She's very disappointed in me.
As well she should be.
As well she could have been a doctor.
Now we got some people. We have some amazing eyeballs on the prize. Welcome, everybody, to this special live stream edition of the Into the Impossible podcast with my friend, my mentor, my advisor, my teacher, I don't know, my rabbi.
It's a way of saying drinking buddy.
Dr. Eric R. Weinstein. How are you today?
I am well-ish.
Well, I've been better and I've been worse. But I'm better now that you are here. And we have a couple of hundred people already gathered around to watch us converse about the future, the past, and the present of physics, of astronomy, of cosmology, and of even things like this golden piece of gelt that I've been fixated on for a long time. And we're going to get some questions from the audience because they're complaining that that you have not had a update on your YouTube main channel with 250,000 subscribers. People are getting peeved. Let's just say it. I put out.
Did I not foresee this and actually post a recent episode of The Portal on my YouTube channel? Brian, you're behind the times, sir.
Oh, okay. It must have been like in the last 20 minutes because I've been checking it hourly.
All right.
So yes, and there's certainly a Portal community, and you should check out Eric's channel, Portal, and you should check out Portal Clips. He has multiple channels. He's gone fully Hollywood, which I salute. And today we're going to talk about a bunch of interviews and a bunch of new topics that I've been getting into as we near the end of the real first season of Into the Impossible, the podcast that I run here from UC San Diego. I've had on many, many guests. None as great as Eric, of course, even despite all the accolades that some of my guests have on.
You've got to be kidding. As the man who's had who have you had recently? Has Sheldon Glashow appeared?
I had Sheldon Glashow.
Noam Chomsky. You're killing it on the guests, sir.
I'm doing well. I'm trying to bring science communication to the masses, and we're going to have on Frank Wilczek next week. We're going to have on Martin Rees, Lord Martin Rees. I'm going to have
just keep coming.
The Astronomer Royal is coming on my channel to tell me my horoscope, as he does with the Queen herself. All right, so we're going to start off with a conversation between me and Eric, kind of riffing on, we chat frequently. You're very generous with your time and your space time. And we're going to talk about depression, a malady that I had this week, existentially getting to, really, what is this channel about? Why am I doing the podcasting that I'm doing? Why is it merely a service to do for the community, which I love, and I love scientific outreach? And maybe should it be an obligation on scientists to communicate? And I want to harken back to our first conversation way back in April, which you can find on my channel in various places. But that was about the awful, terrible, no good job that physicists do with the best material on Earth, literally on Earth, in the heavens, and we do a terrible job, according to one Dr. Eric Weinstein, with publicizing, popularizing, and monetizing what contributions we've made to humanity. What say you, sir?
I think it's still true. Well, first of all, you have to realize that because I'm not a member of your community, but a member of your viewing public, I very much appreciate physics from the perspective of somebody with a bit of a math background who's been focused on the reason for learning mathematics for some of us is theoretical physics. I do think that we see that the physics community has some of the world's most interesting product, if you want to put it in kind of crass terms, and there's a huge demand for it because everyone wants to know, well, what is this most difficult of fields? What is it telling us about ourselves, the purpose of being, reality itself? And yet there's this translation issue, which I sort of analogize at times to not having an orchestra to perform sheet music for people who desperately want to listen to symphonies. So you keep handing out pages of sheet music and everybody looks at it and says, wow, it's a lot of squiggly black dots and lines. And a tiny number of people say, oh my God, I cried. And you're thinking, I wish I could get there, but I have no idea what you're talking about.
Yeah, I often say, we're accused of preaching to the choir, but you have to do that when the choir forgets the melody, right? You cannot ignore it. And in fact, there's no shortage of controversy in our field. I mean, just this week, this epic brouhaha erupted with none other than our friend Sabine Hassenfelder, Dr. Sabine Hassenfelder, who you debated live with me over the summer on Theories of Everything special podcast.
Viciously.
It was brutal. And the Thrilla in South California, I don't know how to say it, but anyway, the point being that she is embroiled with other Titanic intellects, including Lenny Susskind. So she called this
a fight with Lenny Susskind.
She picked a fight with Lenny. She's fearless. She's like, what, 5'2", and she punches, about above her weight. Let's just say that.
Hang on a second. I got something in my throat. Honey badger. Honey badger.
Honey badger. All right. Well, we can't say that. That is forbidden here at the University of California. We may not refer to
honey
any
badger because she's tenacious and she's very rarely intimidated. That was where I was going.
Yeah, but I want. Okay, so I'm going to be the contrarian today. You're going to be the optimist. You're going to be the Pollyanna. I'm going to be the Cassandra. I think a lot of what's happening in physics, it's become fashionable to criticize physics. To say nothing good has come out of physics. Everything in physics is overhyped. That was her thing this week. It was, the black hole information loss paradox, which I want to get into because I talked to Lenny about that this week. She calls that the most overhyped aspect or topic in all of science, and she's sick of it. She says that it's total nonsense, you can't test it, it's irrelevant, and it's by no means the biggest, most important thing, whereas Lenny said that he literally, the black hole war that he waged with Stephen Hawking in his book, The Black Hole War, made the world safe for quantum mechanics. And the reason he said this is that he, as you know, I've been having a lot of debates lately with people like Jan Levin, even, not debates, but she's been on my show. I've had on other people like Lenny, like Sir Roger Penrose. And I said, show me the evidence that a singularity actually exists. I know they're beautiful mathematical objects. I know that they have wonderful, delightful properties. And I said to Lenny, show me an example where you know for certain that singularities exist. And then I'll say it's a problem that we can't unify gravity with quantum mechanics. And nobody can do that. And even Roger, when you were on, you did a guest appearance on my show with Roger recently, and nobody can come up with a reason that there has to be a singularity whatsoever. So my claim is, do we even need a quantum theory of gravity? Sabina's even saying that's not even as important as, or as unimportant, say, as is this issue of the black hole information loss problem. So just to recap for people that didn't see the video, Lenny claims that the most fundamental law of nature, the so-called negative first law of thermodynamics, is that information is conserved. And he claims, moreover, that the black hole event horizon, or actually, to be technical, this thing called that he calls the stretched horizon, some people call the firewall, that's even more quantum than the singularity. But getting back to my point, what if I told you there is no singularity, or we'll never know there's a singularity or not, and we don't know if the Big Bang actually was a singularity, or if it's like Sir Roger postulates, or my friend Paul Steinhardt postulates, that's a cyclic universe. There is no need for quantum gravity whatsoever, so shouldn't you get out of the geometric unity business? In other words, why do you think there has to be a unified theory of gravity with, just because Shelly did it with Lecture Week, do we have to even have a reason to think that it's true for gravity plus the other lighter forces?
You have opened up multiple cans of various sizes of nematodes, sir, and I don't even know what to say. Let's just try to figure this out for the public at large, and see if we can hide our own ignorance at the same time. I guess what I would first start by saying is that what's on the line here is that Sabina has become sort of the curmudgeon to the world of theoretical physics, where you can sort of reboot in Sabina mode rather than safe mode. And she will keep you from being hoodwinked by the various people who wish to sell you snake oil in the halls of physics. Lenny, on the other hand, is one of the architects of the most dominant and appealing theory, and I would say certainly the largest deep program we have. Whether string theory is right or wrong, let us not make the mistake of being anything less than generous at first. It's an incredibly generative structure that has produced a wealth of beautiful mathematics. It may have nothing to do with the physical world, but it is still richer as a theoretical and intellectual system than anything else that is being bandied about as a potential candidate. So there's a lot on the line when the most prominent curmudgeon, whether you think she should be or shouldn't be, that's up to you, is speaking to the most prominent of claimants to the founders of the top theoretical framework under development. What's this really about? It's really about the fact that we're stalled. We should be working on new ideas. We can't quite figure out what to do. So everyone has figured out, in some sense, what he or she is capable of pushing as a series of pawns across the chessboard. Sabina can easily say there's no testable consequences, it's angels on the heads of pins, why do we even need a unified theory? Maybe it's not unified, maybe it's not beautiful, maybe it's maybe. And Lenny can say, wait a second, that's a lot of emptiness. We at least have done some stuff in string theory. We've predicted gravity, technically post-dicted it because we knew it was there. Then he's going to say something about black holes. Now, I think it's really important to sort of get kind of the culture of you guys. Again, I'm not stepping into this physics ring, but in a weird way, the quintessential example of a physical system, if you had to learn one simple physical system and milk it repeatedly, you say it's a weight on a spring?
Mm-hmm. Yeah.
I can't hear you.
Oh.
Oh, no. Have we lost audio contact with Dr. Brian? Ground control to Brian Keating. Brian? I cannot hear you, sir. Oh, no.
There we go. How about now?
I'm not panicking.
You hear me
we can play
now?
charades. Given that the audio is gone out.
You hear me now? You don't hear me.
Three words.
I hear you. You don't hear me. That's weird.
Dark.
Now you don't hear anything.
Matter.
All right, let's try another
Can you hear me,
thing.
Brian?
I do hear you.
You can hear me?
You hear me or
Okay.
no? Okay.
So maybe I'll keep talking and then you keep saying stuff in case they reestablish the audio. If not, we can always try back.
People hear me. Can someone out there say that they...
Brian, I'm going to open or find me on it. Start sending me chats.
I hear you. Eric, let's see. You don't hear me. Let me hold on one second here.
We apologize. Brian, I wonder if I should hang up. You should keep the stream open, and I should try to log back in and see if that solves our problem.
Something. Let's try that because I don't know if people can hear me out there. Yeah, go for that. Do that.
Okay.
Yeah, do that. I believe you can still hear me. Let me see.
Find me on it. Start sending me chats.
I hear you, and people hear him. So I'm going to try to get Eric back on the line here. Everybody hears both of us, so good. Okay.
Apologize.
I hear you. And let me try to get Eric back on. Hold on one second. I'm going to get him back on. Please pardon the interruption, but we're getting more and more people in the chat room, which is good. I tried to switch to a different headset. Now, Eric.
Doctor, can you hear me?
Yes, I hear you. Do you hear me?
All right, I'm going to try. Can you see me?
Now I see you. Do you hear me?
Yep.
All right, great. So you were saying about Sabina as playing this role of Cassandra, so to speak. But I'm kind of decrying it that's become the fashionable way to go about things.
Yeah, and I love the fact that you're giving me an opportunity to be more optimistic by pointing out too much pessimism. right? And
Yep.
so I appreciate the opportunity. I don't usually get a chance to do this. A lot has actually happened in the period that I would say is generally stagnant. And one of the things that's happened is that the foundations of the mathematics underneath theoretical physics has gotten shorn up at an incredible level. One of the reasons I think that we think that this is going to be more unified is that we find certain motifs permeating every layer of the physics stack. In particular, I would say differential geometric bundle theory, whether it's the tangent bundle of space-time, which is kind of the default bundle that comes with the arena in which physics occurs, whether it's this crazy new bundle called SU3 cross SU2 cross U1, which handles the non-gravitational forces, or whether it's what we would call pre-quantum or quantum line bundles that live on top of these structures, which give us the quantization of those classical theories. One of the things that's happened is that we've gotten almost all, I would say all of theoretical physics at its most foundational level now appears to be differential geometric and differential topological. Now there's a huge question. It's one of the reasons why I thought that Lenny was in some sense evasive when you tried to ask him about the singularity. It was kind of an interesting evasion, to be honest about it. But what he said is it doesn't really matter because we don't see the singularity. The singularity in the black hole is screened. So what we should really be looking at is the last thing that we can probe experimentally, which might be the event horizon or the outside of a disk. Who knows? And then the point is now I don't even have to worry about the breakdown of the laws of physics and the challenge to Einstein that's happening inside that, because if the only things I can test are outside, then even if physics is happening on the other side of the event horizon, what's it to me? And then you can also go further and say, look, maybe the classical stuff that Einstein was up to and all of this bundle theoretic stuff of Simons and Yang, you had Jim Simons on your program, you absolutely have to get C and Yang. And when I get you on Rogan, you cannot eat in front of him because he's got misophonia, I think, and he's very susceptible to sounds. As I
no one can see me eating but you.
But I digress. I think that, you know, in essence, Lenny is, he's equivocating. He doesn't know what's going on the other side of that thing. And what I take is I'm processing it for meaning. I think that space-time isn't a crutch to get you to your quantum theory. It's not, you know, there's this very fashionable position, which is we shouldn't be quantizing classical theories. We should be taking the classical limit of quantum theories. Therefore, your attachment to this quaint religion of manifolds and bundles and all of the stuff that makes us feel good as geometers, this is just an intermediate way of getting to the ultimate truth, which has to do with correlation functions and quantum measurements. Now, I think that's kind of ridiculous. Even if you take the classical theory to be effective, it is so astounding in its completeness as a description for the substrate of a quantum theory in the standard model that I think it really raises the question, maybe this bundle structure is pretty close to being right, and that maybe Einstein's a little bit wrong. Mm-hmm. And boy, if Einstein were a little bit wrong, wouldn't that be great? Because a lot of the no-go theorems, think of him as your unfun parent who won't let you do all the things that you want to do. In some ways, you're not going faster than the speed of light, no matter how fast you think that the Ferrari should go. It's capped out. So I think it's really important to realize that one of our best hopes for Einstein being wrong is the idea that a true theory, in a certain sense, and I'm going to say something to make Sabina crazy, but it doesn't mean what it sounds like, shouldn't have these singularities. That the singularities, you said that they were beautiful. I thought that was interesting because I find them to be repugnant.
Yeah, I mean, certainly they are. And again, I don't think I've asked you this, but I've asked a lot of guests, including Lenny and including Sir Roger. And I also want to get to the point of, what do you do when you're talking to somebody, and you've talked to people outside of science, so none of the people I talk to in science are BS artists, but you talk to, besides me, you do talk to people that are sometimes accused of BS. What do you do when you're talking to somebody and you know they're wrong? Like, you know that they're not intentionally obfuscating, they're not mendacious, but they're just wrong. And how do you handle that as a host? I mean, it's and I'm not, by any means, I'm not comparing myself to any of my guests. I view myself as a simple, as I said, I'd call myself a simple plumber, except for the fact that Lenny Susskind was a plumber and Shelly Glashow was a plumber, and actually Lenny worked for Shelly's father, who still has a fleet of plumbing trucks in New York City. But anyway, I digress. I'm a simple experimentalist. I build things, I tinker with things. But actually, I'm going to defend experimentalists later. But I'm not saying I'm brighter than these people, but I know in the case of Sir Roger that he's made some mistakes, and I think those mistakes attest to a confirmation bias that he has, that I pointed out, and I'm not talking behind his back. Lenny is, I don't know him as well, but there are times when I was like, I'm not sure, if Sabina were here, if she would agree with that. I'm not saying I agree with her either. Go ahead.
Give me an example.
So Roger talks about the Bicep 2 data that I played a big part in producing the Bicep experiment, that manifests evidence for Hawking points, for the persistence of memory of black holes that survive through the catastrophic end of the heat death of a previous aeon, going through to a new eon. And he claims there's evidence for this in the Planck data, in the Bicep 2 data, and so forth. There's been proven, I think, pretty conclusively that neither one is true. And in fact, in one case, Eric, what he did was, if the Fourier transform of an image, or the image itself contains a lot of information, but none as much as the hologram of an image, from which you can construct phase and amplitude information. What he did is try to extract phase information from a photograph, which is fundamentally impossible. And I knew that, and I pointed it out to him. And he's still talking about it. And by the way, the paper that I live streamed with him 2 weeks ago about, and he's so super gracious, I love him to death, but that paper was held up in publication up until he won a certain golden gilded piece of gelt. And the question is, does that influence things? I don't think it should.
All right, well, I'm going to make a really crazy argument that is irresponsible and will probably get me thrown off of your channel. But here goes, because we were just playing, right?
Yeah, that's right.
Maybe part of the problem, it goes back to Dirac's observation on Schrodinger. And his point was that Schrodinger delayed publication because there was a failure to fit with experiment. And his claim was that we pushed this on people. Your theory, when it's found wanting, you should capitulate. And Dirac said no. There was a small issue of spin which caused the data not to conform to the theory and its predictions, and Schrodinger was unduly intimidated by this. And so I think what I want to talk about is cheating and theft in the life of a theorist versus the life of an experimentalist.
Yeah, let's go there.
All right. So here's the really crazy idea that will immediately get me laughed out of your channel. The problem is every good idea is dead on arrival.
Care to elaborate?
Sure. We have a machine in physics for producing good ideas. If something is commutative, we say maybe it's non-commutative. If something is symmetric, we say maybe it's supersymmetric. Maybe the symmetry is broken. Are there 4 dimensions? I think there are more than 4 dimensions. What if there were fewer than 4 dimensions? We keep varying each parameter. It's very similar actually to what the neoclassical economists do. They have a concept of a perfect market, and then they relax the hypotheses and they say, if this failed, what would be the consequence? So in a weird way, you hold up this idealized thing, which is the perfect market, and then you violate the hell out of it all the time because that's what produces research. Well, where we are in physics is that physics can't move. The straitjacket has gotten so tight that Houdini can't dislocate his wrist to get out of it. And so if you start piling on all of the experimental indications, all of the no-go theorems, all of the instances where some brilliant person tried for 10 years and failed to make progress on a particular area, we've been failing for so long because we succeeded many years ago so well that it now appears that we can't get to the end, we can't figure out what this is all about, in part because every imaginative idea dies instantly when it gets checked against something in the mind.
In the mind or in the marketplace of ideas and data? I think there's a big difference.
Well, so this is this thing. I brought a guitar, and the point that I was going to make is
I
that
thought you're not a string theorist.
If I pluck the string, holding my finger exactly over the halfway point, I get a sound that vibrates at twice the frequency. That's supposed to be almost exact. If I play the harmonic that divides the string in thirds, that sounds like a perfect Pythagorean fifth. But it's not the same thing as what we would call the even-tempered fifth. Your piano will produce a different notion of the note G than you would get if you played that trick with the string, and it's off by a tiny fraction. In fact, you cannot square compatible. And in even temperament and intervals are like quantum mechanics and gravity. They don't yet fit together. And in fact, in that case, we can prove that they can't be fit together. So my point is, you could then say, okay, so that fifth is not really the perfect fifth, so then we shouldn't make musical instruments that are even tempered, and then nothing will happen. Well, it turns out that that's a really bad thing to do. Your piano works fine, and your ear will compensate for a certain amount of problem, and no one will ever solve it because we can prove mathematically it can't be solved. That means that we get to play the piano rather than just immediately packing up and say, oh my gosh, unfortunately your theory has faster than light communication. Unfortunately, your theory is inconsistent with observational data from a survey of the galaxies. We can see blah, blah, blah. It's important to get enough space to be imaginative. And I sort of think that in part, the theorists have to steal from the till in order to do some business, to put more money back into the till by the end of the day.
Sorry, Eric, your mic's breaking up a little bit. Yeah, it's I don't know if you're on it. But I actually brought this up to Lenny, and I said, part of the reason you're so successful is because you're not on social media. But in reality, there's some truth to that. He hates social media. He feels like it's ultimately a very pernicious entity. And the reason I'm bringing it up is because I had a conversation with Paul Steinhardt more than 2 years ago, maybe, and he was talking about, and he's a very creative. He can think outside the box, and he's a member of the orthodoxy of physics at the highest levels, the Einstein professor of physics. There's that name again at Princeton. Can you hear me?
Can't hear you.
I think it might be your sound system. I'm hearing you. I think people are mixing the audio. Can you say something? It's not coming through again.
Are you sure you can't hear me?
I hear you now. I hear you.
Okay.
You hear me? Okay. But the point is that you might come up with an idea, and then someone takes a picture of it at a conference and then tweets it around the world, and you get ridiculed. So these things become, stillborn, so to speak. Is that what you're talking about? Or are you talking about, like, actually, I show you this plot of data, and I say you abuse the data. You violated the constraints that this data have imposed upon it. Like, for example, we make maps of the microwave sky. We're not seeing it in real time. We have a lot of filtration. We have to get rid of the ground. We have to get rid of time diurnal effects, calibration effects. Those are very hard things to evade, as hard as evading, Lorentz invariance. So I wonder exactly what you mean. Do you mean that, like, these things shouldn't be subject to the same constraints that, say, a data analysis would put upon them?
Well, think about it in terms of our history. There used to be something called the tau theta puzzle that had to do with weak interactions in beta decay. And the tau theta puzzle sort of created a paradox, but it assumed that the universe was symmetric in a mirror. And the solution to the tau theta puzzle involved, what if the universe actually had a beauty mark like Marilyn Monroe or Cindy Crawford, so that you could tell, right? So I have a few moles on my face. You can tell whether it's flipped.
Yeah, that's right.
So, but I thought people would rather think about Cindy Crawford.
Yeah, that's true. Yeah, Marilyn Monroe than either one of us.
So the situation there was that it was very painful to propose the idea that maybe the weak force, different from all other forces, would decide that it would break this kind of mirror reflection symmetry. And who knows why? I mean, it's one of the most astounding discoveries in the history of physics that that's true. But Feynman gave a description of being at a conference or something in which some lower ranked person said, why are you guys so keen on the idea that the universe has to be left-right symmetric? And Feynman said, I'm asking this question for so-and-so. Everyone claimed that he was doing that to humiliate the guy because he wasn't strong enough to do it himself. Feynman says, no, he would have been able to. But this gets back to the issue of disagreeability. Now, disagreeability is one of the things that leads people to being called a-holes in science, because you don't go around along with the crowd. I've interacted with Lenny before. He's not an a-hole, but he's grumpy. He's highly disagreeable. He's got the strength to say things that other people wouldn't say.
You know what's amazing about that? Before you go on, I asked him, I asked Shelly, and I asked Barry Barish. I said, what thing did you not know, when you were 20, that because you had courage to go into the impossible, as is the name of this podcast, now you believe to be thoroughly, eminently feasible, but only because you have the courage to go a little bit into the impossible.
Sure.
And two of the three of them said it was overcoming imposter syndrome. That basically, so two. That means one of them was a Nobel Prize winner. Can you guess the one that wasn't? That didn't say he suffered from imposter syndrome?
And what is my group?
The group is Lenny, Barry Barish, and Shelly Glashow.
I'm going to guess that Shelly does suffer from it. He did suffer from it. And I don't know Barry Barish.
It was actually Barry and Lenny.
Okay.
Barry said, and this gave me chills. It gives me chills to talk about it right now. He said when he accepted his Nobel diploma in Stockholm, he was asked to sign a book. And in that book, when he received this medal, he said he wasn't intimidated by this. He was intimidated by this. He saw Einstein's name.
Yeah. He
panicked. And I haven't released the interview, but it was one of the most deep interviews I've ever done. And it's just so touching that this guy's a Nobel laureate. And he could talk for hours. And Lenny is like that too. When Lenny got over imposter syndrome, he was 50, he said. Full professor at Stanford University. Feshbach professor, I think he is. National Academy member. He says it wasn't easy. And that disagreeability, which I think you have a confidence, you have a swagger, and I think that has served you, but also I think it pays to have a little bit of insecurity. I have a question from one of my listeners who wants to, I think it's harkening to your interview with Lex Fridman. I want to get to it because he paid $15 to ask this question. Thank you guys so much out there. It goes into my Nobel Gelt collection fund. So this is Elon.
Wait, how much did he pay for this?
What's that?
How much did he pay for this?
He paid $15 for it, and then
I'll answer it for $8.
Oh no, you can't do it now. We can't do it. Okay, so fine.
No, it's a Jewish joke. Anyway, keep going.
You're trying to undercut the marketplace. Elon Tusk is asking, Eric, when you say it's time we got off this planet, please explain to us, which I think you did with Lex Fridman. Please explain to us what this looks like if my less successful cousin Elon Musk were to implement this technology, assuming it's possible, to his ship. So in other words, what does it look like to get off this planet? I guess he's not asking the question I would ask. Elon, you should have asked this question. Why is Eric concerned with getting off this planet? But he just asked you the technical question. Sorry, Eric, can't hear you. Give me a response in the chat room. Can you hear me in the chat room? I don't hear Eric. I have not changed anything. Does anyone hear me? Please type in the chat room if you hear me. And, Elon is a Jew as well. Interesting. I don't know. Nobody's perfect. Just kidding. So, Eric, do you hear me? I don't hear you. Does anyone in the chat room hear Brian? Please let me know. Elon's technology took us offline. All right, it looks like he's coming back. You don't hear Eric, but you hear me. So I will now play my guitar. No, I can't play anything. The only instrument I play is the iPhone, and I don't even play that very well. All right, let me call Eric back. Yes, you guys are all saying, I'm going to tell this to Eric. I'm going to tell Eric. Eric, are you there? Can you hear me, Eric? Active now. He has to invest some of Elon Musk's money into a microphone. Eric, can you hear me?
I can hear you.
Okay, now I can hear you. Okay, so Elon is giving us this money, and I want you to use it to get yourself a quality microphone.
I hear you.
And this is good. Okay, everyone in the chat room, tell me if you can hear Eric now. You guys all hear me? Okay, good. It's when you guys talk at the same time, Eric falls off. Anyway.
So now I've changed my microphone and my camera, and people are going to be angry because my Dell computer is going to be looking up my nose. You're going to see that comment a lot.
I've only heard that. The only thing I've heard more than that is, when is Eric going to publish his theory of geometric unity? That is verboten. We're not talking about that today, folks.
Okay.
All right. How do we get off this planet? Just how, not why. How?
Well, I think part of it would have to do with using degrees of freedom that, if there is a way, and if there is any, first, there's like a lot of ifs, so just assume that we go through the boilerplate. Assume that the theory was right, assume that in some sense 14 dimensions somewhat replaces 4 dimensions. We have now 10 extra dimensions. It might be that you'd be able to travel along those 10 extra dimensions rather than along the 4, and it might be then much more economical, let's say, to come up, to move along the 10 dimensions, then move along the 4 where it's easier, and then to go back up the 10, and now you're somehow farther apart. I don't even know whether that's a sensible thing, but the key thing is we're a bunch of co-traveling waves, and in my estimation, we think we're co-traveling waves in 4 dimensions, but we're actually co-traveling waves in a larger space. And that larger space includes the rulers and protractors of Einstein's space-time metric. And so if those are actually legitimate degrees of freedom, try to imagine, like, you could, at least theoretically, you could imagine if I shrink all of the distances by expanding the rulers, then suddenly, my first operation might be expand the rulers and then move in that new world where a mile is now an inch, and then contract the rulers. So that would be the kind of, by incorporating the space-time metric as one of the degrees of freedom on which waves can propagate, there might be something to do like that. But the key point is you need to know what the full source code is before you know what you can and cannot do. If we have our current picture as a bunch of effective theories, you might have no-go theorems in the effective theory that aren't no-go theorems in the ultimate theory. And so the question is, does the ultimate theory inherit the same set of restrictions as we currently have in our partial theories known as general relativity and the standard model? I hope that was worth your $15.
All right, well, now we have a bidding war because someone is asking a $20 question. See, it's very profitable. This is why I do these super chats. Okay, this is from a man who has a name that I
promise not to sing for 50.
Well, I was saying, you asked me if I can play any. Someone's asking me if I can play an instrument. I said yes. I played the iPhone, but not very well. A super chat from a man or woman by the name of R. Maybe it's the software R. Anyway, yeah. 2 questions. So he wants or she wants 2 questions. What is the role of category theory in physics? And what do you think about teaching advanced mathematics using computers? For example, use Mathematica. We're going to get to our conversation with Stephen Wolfram not too long from now. And Sage Math, I'm not familiar with that, to teach advanced differential geometry. So 2 questions. Category theory, I guess, should we teach it at an early age when we teach, calculus? And then also, what's the role of computers in the teaching pedagogy of mathematics? Thank you, R.
So first of all, for those who are not familiar with category theory sort of got forced almost on the mathematics community, because you would notice that certain patterns were highly conserved. So something that seems to be about algebra, and like the algebra of symmetries, might also be true for spaces and geometric objects. And so you would notice that certain relationships in very different sounding places were carried over. Categories of things are in fact related to each other through things called functors, which are sort of like maps of theories to other theories. In essence, we do category theory for two reasons. One, we do it to clean things up and to get to the heart and elucidate what's really going on at the purest level, not to be distracted by the instantiations, which may appear different, but it's the same thing in different guise, same sort of underlying. It's sort of a way of dealing with Platonic truths rather than examples of truths. The other reason we often do it is to avoid work. We don't know what to do. So we say, okay, well, how does that work category theoretically? Maybe we should use 2 categories or 3 categories. You make things more and more abstract to avoid a reckoning. And so there's a good reason to do category theory, which is usually not essential, but it's very helpful if you know how to do it. And then there's this other thing that we do, which is that we sort of go into, mathematicians have this phrase that they call it abstract nonsense, sometimes affectionately, sometimes in a derisive way. How does it relate to physics? Well, what we have, a good example of this would be quantum field theory. In a weird way, quantum field theory takes initial states and asks about the transition to final states. But we have another geometric theory called Bordism theory, where you have an incoming manifold and an outgoing manifold that look like incoming and outgoing states. And then in the 1980s and early 90s, we sort of found out that these two things were the same. And that kind of category theoretic version of some sort of equivalence where something quantum field theoretic and something differential topological were actually the same underlying thing. So I think that there's lots of things that category theory can do if you happen to have a very nice formulation of a theory that makes sense as rich mathematics. I also think that it's a way of avoiding our more fundamental problems in the subject. So I hope some of you will not listen to me and will show me that category theory actually breaks the logic.
Now, I should point out that you and I have formed a partnership, a super group, which also will involve a certain young Weinstein, not young Einstein, but a young Weinstein, and that we are working on the second part of ours question, which is about teaching pedagogy of mathematics. Does the computer enhance it? And I don't know about Sage Math, but we had a live debate this summer with Stephen Wolfram. I'll put that in the chat room right now, but just so people can refer to it. By the way, if everyone's out there sitting down, your fingers are getting numb and at risk. This is my advertisement now, okay, Eric? Now we're going to make some real money. Your fingers can get carpal tunnel syndrome unless they're exercised. So please take your finger, stick it on the subscribe button to this channel, and that will do me a big favor. Because we want to get more attention for live streams just like this and the one that we did this summer.
Love the hustle.
What's that?
Love the hustle.
Gotta hustle. Gotta hustle.
Gotta
okay,
hustle.
so what do you think about teaching young Zev and others mathematics by using Mathematica, for example, by our friend and compatriot in all things theoretical of theories of everything, Mr. Dr. Stephen Wolfram?
I think it's great, but you have to know what some of the problems with it are. So one thing I would say, for example, is that let's imagine that you have a matrix, a matrix with 2 rows and 3 columns. Sometimes in the computer, it makes a difference as to whether it's if it's 3 rows of 2 columns or if it's 2 columns of 3 rows, in some weird way that's irrelevant to the mathematics, but makes sense as to how the memory is allocated inside of the computer. So I think it's very important to make sure that whatever you're doing in a pedagogical fashion using the technology, you keep track of the ways in which the technology actually fails to mirror reality. For example, in the original formulation of Python, there was a problem with the ring of integers where the brilliant founder of Python, Guido van Rossum, had an idea that the product of two integers is an integer, so that if you divide one number by another, you should stay in the same class. But if you divide 7 by 3, that's not an integer. And so he cast it to the nearest integer. That was an example of something where you thought you understood what you were doing inside of the computer. I'm dividing 7 by 3, but you might find out that you're going to get either the number 2 or the number 3 unexpectedly. So you have to keep track of what it is that the computer is actually doing versus what did you think it was doing. But I think it's a great, Sage Maxima, Wolfram's Mathematica project. I would also point to our friends in Austin, Continuum Research with the Anaconda release of Scientific Python. All of these are very helpful tools, but don't, just know where the map between the real math and the computer's representation of it breaks down.
Mm-hmm. Okay, we have another friend, this time across the pond, I presume. Walter Bishop chipping in with a 5-pound note. Question for Brian and Eric. Up to what point do you agree with string theorists before the disagreement branches out? So I want to say before I ask that question, I asked Shelly Glashow this week, author of this really wonderful book that I want, this copy is for Zeb when he comes down to visit. I want to know, he has a scorecard, he has a rubric, and I'm going to go all through it with you to ask what in the 32 years since this book was written, it's a wonderful book, it's actually probably the best book on the pedagogy of elementary particle physics of unification. And we went through, in this video I'll post probably next week, and reminder, I'm going to have people on, I'm trying to get Gerard Hooft, I hope I'm saying that right, I'm hoping to get the big dog.
Ed Hooft?
I'm hoping.
Who knows?
Yeah, I think it is. I think I'm going to try to get Ed Witten. Speaking of string theorist, Walter Bishop, I'm going to try, but I'm going to need a lot of help out there because he doesn't do podcasts, or so he says. Anyway,
he did one.
What's that?
Ed Witten did one.
He did one. Yes, he did one. You have to rub that in. Thanks, Eric. Thank. And you're the only EW who comes on the podcast. So why are there
I'll race you to Ed Witten. I would love to.
Now, you never read this book, but you actually resonate very well with it. So here's the first thing that you and I ever talked about. Why are there so many basic particles? Why are there so many free parameters? Why does the number 3 play such a big role in elementary particles? And how many families are there all told? So he asked these questions, presuming he'd find out answers, before the year 2000, let alone the year 2020. Hopefully, may it be gone and forgotten soon. Although I'm hoping it's been 5780. That was the problem. Now we're in 5781. Things are smooth. Anyway, what do you make of this? That we haven't made progress since this book was written, and not for lack of spending money. And then I'm going to give you something really. I'm going to say it's a good thing that the SSC was canceled. But for now, please answer this question. What grade would you give these 3 different problems? Why are there so many particles? Why are there so many free parameters? Why does the number 3 come in? What grades would you give to theoretical particle physics?
Well, it depends what you mean. So let's do the first one.
Yeah.
Why are there so many particles?
Yes.
I would say that he's saying that the number 3 matters because there's 3 collections of 16 particles with sort of 4 space-time states apiece. So that's all of that is coming from trying to figure out how to say this to a partially lay audience, but in essence, we have these 4 gadgets called Lie groups. Never mind, they're collections of symmetry, but the full name of it would be SL2C cross SU3 cross SU2 cross U1. And then you have to specify a particle by giving some idea of what those groups of symmetries symmetrize in the form of something called a vector space. Now, it turns out that partially due to Shelly, there's a hidden kind of agenda almost in this, maybe, which is that Shelly was one of the first people to talk about so-called grand unified theories. Now, because we have to make everything difficult for the guests like me in theoretical physics, you'd think grand unified was more unified than unified, but it's less unified. It's only 3 out of 4 forces. So we do that to throw off, the Russians in case they're going to invade or something like that. We don't know. So you have this weird thing, which is that Shelly figured out a model called SU5, which reduced the numbers of particles, in essence. The space stayed 16-dimensional, but it really broke up as 1 plus 5 plus 10. And then there was another theory called SO10, which again should have been called spin 10, but the physicists have the wrong name. I don't know why they do that to me. And what they do is they put everything in one 16-dimensional symmetric situation. So the number of particles goes down in a certain sense, but the space of the particle expand. But I think it's, if you believe in the so-called SO10, which is really spin 10 theory, and then there's a different version of this called Petit Salam. You can grade me to see whether I'm a good tourist here. That theory is very similar to the SO10 theory, but it's slightly different. It makes use of something called spin 6 cross spin 4, otherwise known as SU4 cross SU2 cross SU2, never mind. That theory, both of those indicate that there's a lot more unification. We just haven't seen that it's true yet. So I think that the idea is that we actually have a speculation that there are fewer particles in a certain sense once you heat things up to see the hidden symmetry, and that they're just fewer numbers of more capacious particles in a certain technical sense. Mm-hmm. The number 3 is mysterious because of the number of generations experienced. People think that they've seen 3 copies of Lego. Imagine that you had a Lego set made of plastic, one made of wood, one made of lead. The Lego would sort of be the same shape, but the weight of each set of Lego would be different. Now, is there a tungsten platinum set? Is there some other platinum set? Is there some Lego set beyond the 3 that we know about? I actually claim that we only have 2 generations of matter, and that because what's really happening in my mind is that for something to be a true generation, it shouldn't just be a generation at low energy. It should retain the same properties as the others when you heat them up. So if you have 3 things that look the same when they're cold, but only 2 of them look the same once they're heated up, then you might have only 2 generations, or maybe there's only 1 unique generation and there's 3 different versions of it, and they all look the same when they're cold. So I've never heard anyone in my life say that. I don't know why, but I believe that that's a consequence of my theory, that there are only 2 generations, not 3, whereas everyone else would say, we know that there are 3, maybe there are more, but there are limits on it from astrophysics. What are the other questions?
The number 3, why are there so many parameters? Why are there so many particles? There are some things that there is a grade that I would say is higher than an F minus, which I used to get a lot of in high school. Such as, are neutrinos massless? He asked that question back in 1988. Now we know they're not massless. At least one of them has a mass. We know that surprisingly from astrophysical experiments, not unlike the ones that my colleagues and I do on the Simons Observatory, etc. Cosmic microwave background, baryon acoustic oscillations, etc. People are asking, so we got a 50 krona, I don't know, I think that's about $7, I'm not sure. 50 kroner a question. And actually, it's not a question, it's just how to pronounce that ooft. So thank you very much from Norway for that. People are questioning, again, how do we fit and reconcile the need for something when there may not even be evidence of lack? In other words, is there a lacuna in physics when if the old one, as Einstein called God, hands us a piece of paper and it says there are no singularities at the center of black holes, and there was no singularity in the early universe. Sir Roger's right again, or Sir Paul Steinhardt is right. There is no singularity. Would you give up GU?
Sorry, I don't think there is a singularity.
Okay, so singularities are not part of the motivation to unify gravity with the other higher energy forces.
Well, this is the uncomfortable part. One of the problems is that we love Einstein a little too much. We sort of treat our great physicists as heroes, and then we make the mistake of taking the top of our pile, and they stop looking like the rest of us. I don't think that Newton and Einstein have the same sort of feel, even Dirac. I mean, weirdly, Maxwell, I think, did this unbelievable work, but I don't think that we live in terror of Maxwell. I don't know why that is. Maybe it's too far back. Weirdly, Newton, because of the calculus, everybody's in awe. I think that the great fear is that we're afraid to challenge Einstein. Most people who challenge Einstein do it because they don't. It's sort of like picking a fight with Khabib Nurmagomedov. If you were smarter, you wouldn't do it. So dumb people pick fights with like the the most dangerous people
Well, you
around.
remember that, yeah. I always compare it to like Dungeons and Dragons. I get these emails literally every day. I'm sure you get them too. And it's like, Professor Keating, Einstein was wrong. I can prove how. And if you help me, I will share my portion of the Nobel Prize with you. And I told it to Adam Rees, who won the 2011 Nobel Prize. And he said, yeah, how do you think I got this? You know, I answered one of those emails. Someone's asking a young Weinstein. Let's say there was young Weinstein. Like I have
Well,
young...
I wanted to get to the previous
Oh,
one.
yeah, go finish that, yeah, and then we'll get to it.
So the point is that the singularities give me confidence that Einstein isn't the last word, that he's correct in his domain, but that, you know, he had this wonderful thing about, or this aphorism about my equation is like a house with two wings, one made of fine marble, the other made of cheap wood. And one side of it comes from curvature and geometry, and that was the marble side. And then the other side was like, you just throw together whatever it is that creates something called the stress energy tensor. And I always thought, okay, what does a contrarian do? The contrarian imagines that the problem is with the marble. And is there a body buried under the marble? Is Einstein, are we so afraid to talk about Einstein's greatest achievement that we're giving him a kind of reverence that's holding us back? And so I think you both have to sort of go after Einstein, but it's going to be imperative that you restore him once you take him down from his pedestal. And none of us really want to do it because, quite frankly, we love him. I mean, we love him because he was everything we wanted to be. He was right about the most important, crazy things. He was decent. He was wise. You know.
Yeah.
So
no, it's true. But yeah, I mean, sometimes you have to kill your father, and you know. Well, I don't know what you do after that, but.
So you're going to take over my son's tutelage and tell him that. Great.
No, you will withdraw your tuition.
The singularities give me confidence to say I don't think that Einstein is the last word, and I don't think non-physicists and mathematicians. It's a little bit weird that we're so reverent for one of our own, where there's still people walking around who met him, and I think we haven't gotten over our Einstein issue,
yeah.
and we won't until he's made into an effective theory, and that's coming.
And even as I said, the great Nobel laureates and the others still suffer from imposter syndrome when they get confronted with even just seeing his signature gives them. Yeah, I mean, what else is it? But by the way, Eric, I mean, I also feel like, and you know from my book, Losing the Nobel Prize, that I feel like this medallion and even the recognition, the hero worship, is a form of idolatry. I feel like we worship people, and ironically, many of us profess to be agnostic or downright atheist. Lenny is a hardcore atheist. And yet, when we were talking, and this happened with Gad Sad, I had Gad Sad on my channel, who's a devout, practicing atheist. And he was quoting things, basically unknowingly, quoting from the Shema and from other canons of Judaism and Christianity. And so was Lenny. Lenny said, what's the most important thing? Because I ask all my guests, as I'm going to ask you in about 15, 20 minutes, you know, what would you put in your zava'ah, and your ethical will, not your material will? I know most of that's coming to me when you're 120, but that good teal scratch, it's coming my way, baby. But I want to know what you put in your ethical will. Shelly refused to answer that question, Glashow. He would not answer that question. First time it's ever happened to me. It's kind of awkward, to be honest with you. But Barry answered that question, and Lenny answered it basically as justice, justice, you shall pursue. Now, these are these atheists. They're all Jewish. It happens to be there have been some Jews, and there have been many people believing Muslim. I've had on Marwa El-Dwini. I have to give her a shout out. She's your biggest fan. She wants you on her podcast even more than me, which she had on. So she's a devout Muslim, and these most of scientists would believe and profess to be atheists, and yet they worship Galileo. They worship. Eric has been knocked off the channel just as we were talking about God. Can you hear me, Eric?
Wait, what?
Are you there?
Can you hear me?
Yeah, I hear you.
Yeah, I'm here.
Okay, so what do you make of this hero worship? Is it hero worship? Like, we want to feel like there are people that are these super ninjas of the brain, and that, like Jack Nicholson said, you want me on that wall. You need me on that. We need them. What do you think?
I don't know. I mean, I feel like I've met my heroes and they survived.
And you survived.
You know, I used to hang out with this guy Isidore Singer, Isaac Bashevis Singer's cousin at MIT, and you don't find people at that level of intelligence in everyday life. It's true, it's real. You know, every week you have lunch with the same person. I weirdly sort of don't have this fear of hero worship. My feeling is you don't know what the human mind is capable of until you get into a small number of areas that prove, you know, I mean, look, Eddie Van Halen and Art Tatum prove it as well as Paul Dirac and Albert Einstein.
Yeah.
But there are just certain things the mind can do that nobody's prepared for. And when you met somebody who's touched the cosmos in that way, they are altered.
Yeah.
You know,
and yet they put their pants on, you know, one leg at a time, right? Eric, your microphone is a little scratchy. Can you, is there anything you could do to it? People are saying how slim you're looking. Maybe that's causing it. I'll use this option to remind people to take out their fingers, stretch your digits regularly, push the subscribe button on this channel so we can grow and continue to get guests like Ed Whitten, hopefully someday, another EW. And I'm going to ask Drew's question. I think this is a fascinating question. What area of STEM is most ripe for disruption or paradigm shifts? In other words, I'm going to ask that in terms of where would he advise his children to go into, and my children to go into. What field of science is most ripe for disruption? Eric, can you hear me?
I can. Can you hear me?
Yeah, it's very scratchy. You want to use your phone? People are saying to use your phone. Maybe let's try that. Do you have your phone nearby?
I do. Let me see what its battery situation. Oh, 3%. Well done, Eric.
Oh. These theorists.
Let me see if I can. Is that any better?
That's much better.
Yeah?
Yeah, much better.
Okay.
Okay, good. All right, so where would you send your children or my children? What area of STEM is most ripe for a paradigm shift or disruption?
Well, I mean, obviously the things that are new and have a lot of novelty are what get people. So you're going to see a lot in machine learning, a lot in distributed computing. You're going to see a certain amount that's kind of new and exciting. Well, look, I'm going to go in an opposite direction. I think it's theoretical physics and fundamental physics at that. And I think that there's no indication that this is about to happen that is generic. And that's why I feel excited to predict that a stagnant field is going to move. Mm-hmm. But I think it's been pretty stagnant for a very long time. Again, there are a lot of caveats to the word stagnant in that sentence.
Yeah.
But I don't think that it's easy. Look, nothing is working the way it should. You can't get a PhD in any field that I'm aware of and have an expectation that you're going to become a professor.
Yeah, it's extremely unlikely nowadays.
Yeah, so I think that in part we just have to recognize that we have got to take the system back. We've got to get tons of money to our best people. We've got to stop killing off everybody who, you know, gives it a shot, either by bouncing them out of the field or working them to the bone or threatening them that if they don't follow the fashions, they can't be employed. We have a terrible situation, and it's up to people like you and me, Brian, to let the people who've been in charge of this for too long, we have to tell them, your time is up, it's over. We need to revitalize these fields. These need to be careers. These aren't, it shouldn't be that you spend, you know, your life to age 35 before you find out that you're not even employable and you can't have children and your spouse can't live in the same state as you. This is preposterous. And I think I'm just sort of embarrassed about the question. In the richest nation in the history of the world, I'm actually telling you, don't go into science when we desperately need it. Come on.
Yeah, I wanna make a provocative statement. Are you on your phone, by the way? Where are you on now? Because we don't see your lovely visage. To some,
is that right?
What's that? I hear you great, but I don't see you at all. There you are.
Okay.
It's a little scratchy still,
yeah.
but yeah.
I think that the problem is that don't send your kids into STEM until Brian and I get to the National Academy of Sciences and turn over a few people and shake money out of their pockets into the coffers to pay for young people to actually have careers with stability and freedom. And it's also incredibly important that we get some of the transparency out of the field, because you need the freedom to think crazy thoughts We are doing safe science, and I personally think that our desire to not waste taxpayer money is wasting taxpayer money.
Yeah.
What you need to do is to give the money to people who are dangerous, people who are original. Let them figure out who they need to fund. Make sure that it's not such a cutthroat environment. And let's get on with it and get back to being Americans. It is the greatest scientific country in the world, bar none.
So I want to conclude with a couple things that are on my mind. One is very provocative, which is that I was talking to Barry Barish, winner of the 2017 Nobel Prize for Detection of Gravitational Waves using LIGO. Very wonderful man. He was working on a project called the Superconducting Super Collider. And they had been working on that for many years. And then it got canceled in 1993. Congress canceled it. I make the statement that that's a good thing. And in fact, perhaps he wouldn't have won the Nobel Prize, and maybe LIGO would never have succeeded because he was the decisive person, along with Ray Weiss, who will be on the podcast too. Another reason to subscribe. He's coming on the podcast soon. These are guys who are getting up there. I'm trying to get women, by the way, and they just won't come on the show. I don't know why. Well, I know why. I asked Donna Strickland, who is a hero of mine.
She just hit Jen 11.
I had John Lem. I'm saying Nobel women. There aren't many, but I'm trying my best to have them on because I really want to feature them because I have a lot to learn from them, and we both have daughters, and we want to be inspired, and our sons too. But anyway, she just doesn't do podcasts, she said, and I'm trying to get a hold of Andrea Ghez, who's a colleague at UCLA, but it's been tough. Anyway, I want to get back to this. SSC cancellation. My controversial opinion is it was good because Europe ended up doing it. It was built to detect one thing, which is the Higgs boson, effectively. I mean, people can argue with me. Cost $20 billion when you actually add up the money. And by the way, whenever a physicist tells you something is going to cost X billion dollars, always double it, because to operate it costs as much as to build it over 10 years. It costs 10% per year to operate of the construction cost. That's operations rule of thumb number 101. So if he had stayed on the superconducting super collider, we would have spent 20, maybe $30 billion. We would have detected the same thing, maybe a little bit earlier, maybe not. And he wouldn't have worked on LIGO, and LIGO wouldn't have succeeded. So it's a good thing that that SSC got canceled. What do you say?
Wrong.
Okay, tell me where I'm wrong.
Well, first of all, we pissed off Congress. And we lied to Congress about a science shortage. And if you take, for example, our mutual friend Rabbi Walpe, his cousin, Howard Walpe, held hearings, and the basic question was, why did you, the National Science Foundation, and you, the National Academy of Sciences, lie to us? You had a special deal with us, and you stupid effing morons, in fact, concocted a scheme to, for some reason that we can't figure out, to do shitty science inside the National Science Foundation, National Academy of Science. You bamboozled us. You got us to pass the Immigration Act of 1990, and then we find out that, in fact, this is an incompetent demographic study because it didn't take demand in the labor market. This is the same time that they also said, what are you doing buying art for the SSC at these prices? And quite honestly, I'm incredibly disappointed with the senior leadership of the physics community, for one, not understanding the political sensibilities in Washington, but also not leveling with them, which is, you take our toys away from us, you're going to screw yourself over. In effect, we have intellectual SEAL Team 6 at your disposal. And what we like to do is to train and work out. We work on physics, but we're available to you guys. And this is an advanced technological nation that brought forth atomic weaponry. You need your best and brightest to go into these fields and to make sure that you're current, given, for example, that, you know, the World Wide Web, for example, came out of CERN. There is no question in my mind that if you try to do a cost-benefit analysis on why are we spending so much money to look for particles for these people, you're getting it wrong. We are at almost the end of perhaps the greatest story in the history of the world, and we're acting like a bunch of putzes. And $20 billion is not that much for the people who helped end World War II with two monstrous weapons dropped on our now ally Japan, which is incredibly horrific for all those who died, but it was also the decisive end to World War II. your communications devices, the semiconductors in your phone, almost all of this comes from theoretical physics. As much as I really often dislike dealing with theoretical physicists, but it's like, I'm sure I wouldn't do SEAL Team 6. They'd probably think I was a pussy. On the other hand, do I want SEAL Team 6 to be well-funded and to be there whenever I need them? Absolutely. Well, this is what it takes to get the world's smartest engineers, the world's best mathematicians, the world's top physicists and minds working together to be available to our government and our country when we need it, and to make progress and potentially, you know, let me turn it on you guys. You guys brought us into the valley of death, and the only people who are going to get us out of the valley of death after the atomic weapons of World War II and then the fusion devices that followed in the early 50s, the only people who are going to get us off the planet are physicists. Elon started as a physicist, but those rocket engines aren't good enough to get us diversity beyond the solar system. We need a huge number of different planets to experiment with so that we don't all go up in one fell swoop on the one that we have.
Right.
So the short answer is we pissed off the government. We changed our agreement with them catastrophically. It was part of 2 separate sets of hearings. And quite frankly, I think it's the mismanagement of the physics community's legacy by senior physicists, and it was a horrific thing to lose.
So I want to give some news to folks that we are going to be working together on a project for revitalization and in concert, experiment and theory working together. Eric and I have plans for this. Stay tuned for that. Again, please subscribe to Eric's channel, the portal clips, and listen to episodes. I believe I will be on an episode in the not too distant future before the universe doubles in size. We've recorded an episode. Someday that will be available, and I want to thank Eric for that. I want to close with a couple more questions from the audience. We have one from Russia with love, and that, if I can find it.
By the way, just to come back to, at the very end, let's come back to the question about what to do with a guest who says something that you don't feel comfortable
with. Well, let's do that now, because
yeah,
time is running out. The day is short. I want to know. Yeah, I'm dealing with guests, and this week was this kind of up and down roller coaster for me. I had, just being honest, I had wonderful guests that were really edgy, interesting, controversial, but don't even care about their legacy. I had other guests on this week that are very considerate of how their reputation is handled and not wanting to be too controversial, even when I know that they have controversial opinions. And I'm not like here to be Jerry Springer of physics, but the bottom line is I think that they sometimes will manage an image in a way that is contrary to what is best for at least my audience. Now, maybe they don't care about my audience, and why should they? Uh-oh, we've lost Eric, but we haven't lost me. I will keep going. So the existential crisis that I faced is whether or not to involve Eric. Can you hear me?
Yes, Brian. Sorry, you said you had guests on. You had a tough week, and then I couldn't hear anymore.
Yeah, no, just having guests that are generous with and open and willing to be vulnerable, and I think that those are the most interesting people, and they help demystify the Einstein syndrome that we were both decrying. And when I'm dealing with that, I'm like in real time. First of all, I want to know, Eric, when you're interviewing somebody, do you have a metric that you're using, like, I'm doing a good job with this interview, or I'm doing a bad job? I found I have one or two, but I want to hear, what are your tips as podcasters, especially with really intellectual guests that you get on, excluding me?
I haven't solved this puzzle. I talk over people too much. I'm too aggressive. Sometimes I don't want to embarrass somebody, and I maybe shortchange the intellectual. Sometimes I want to do the intellectual right, and I feel like I didn't take care of the person properly. There's a huge number of competing pressures. And I think people see us failing at one thing or the other. They don't realize that it's not because we didn't consider, maybe I should shut up, maybe I should let people finish. It's sort of like, wow, if I don't say something, then this is going to go on for a 20-minute riff and we're going to lose the audience. Okay, so in this situation, I had a little bit of this situation with Garrett Lisi. I like Garrett and I care about him. I think he's very imaginative, and I think he brought a lot of good ideas into the world, even though I think his theory is wrong. I don't make a secret of saying that his theory is wrong, but it's clear that I hold him in high regard as a human being, that he's generative, that he's original, that he's trying all sorts of positive things. When I interviewed him, I guess he had decided that he had moved from E8 to an infinite dimensional version of his own theory, and that this was the solution to the problem. And it was a significant enough pivot that I didn't know how to address it entirely. Because I sort of felt like you should at least acknowledge that the other thing didn't work, and maybe this pivot works. But one of the problems in startups is that if you keep pivoting, then the question is, was there something there at all? And I think that Garrett had a really interesting, good idea that doesn't work. In the case of in Roger's case, I interacted with him, and there were some places where I feel like we didn't have a satisfying intellectual connection. So I think that that's normal. Mm-hmm. And I think that when you love people and your friends, like it's possible that you and I could talk about geometric unity, and you would say, well, isn't that a minus sign? I'll say, no. Oh, is it? Oh, really? Did 35 years of work just go out the window? It's a nightmare, and it's funny. It's hysterically funny that we live our lives like this. But the thing is, what else can we do? I mean, at least we're trying. At least as a theoretical physicist or mathematician looking at this stuff, you're trying. And if you fail, all that can be said is nobody else figured it out either.
Yeah, you failed daring greatly, like Teddy Roosevelt said. So when I'm doing something, I want to get your opinion about. If I'm interviewing you, or I mean, you and I are good friends, but if I'm interviewing a hostile witness, and I hear them say something like, "That's a good question," I kind of think that is a good question. Whereas I hear them say, "Well, as I said before," then I realize I'm not doing so great. Or similarly, when somebody says, like, they just stop and think, and I let them try to hang themselves, not hang themselves, but I let the silence do the work. And I wondered, do you have this loop in your head to be a good interviewer? We're not trained in this. We're doing the best we can.
See, I try to embrace things like, you said imposter syndrome. I've listed my occupation as imposter on numerous occasions. I talk all the time about the fact that I'm not a physicist, and here I am opining on these shows and blah, blah, blah. In all of these circumstances, you have to sort of play with it and make fun of it. I'll be honest, when you said Lenny Susskind is obviously incredibly successful, I had a moment where I said, is he? I understand that he's very highly regarded and he's contributed many theories, but does it cash out properly? If I were to list Qumran Vafa, if I were to list Ed Whitney,
who's going to be a guest next week, Qumran Vafa. No. Yeah, that's a good question. I have a question for you. I'm sorry to interrupt, but time is short, and I do want to get to a few things for you. And maybe we'll do this again next week. But the point, Eric, is I say this, another provocative thing, which you'll probably shoot me down for, but I say it wouldn't have made a difference if a lecture week unification was discovered in 1962, as it was by Shelly Glashow and collaborators, or if it was discovered in 1982. But it would have made a big difference if the transistor wasn't discovered in 1956 and instead was discovered in 1976. So I think that there is sort of a fungibility in some sense of theory. In other words, theory is going to be discovered, but experimental or inventions, which is what Alfred Nobel wanted to recognize. I mean, what do you say about that? That there's sort of this time value of money, and that we really should invest it purely in experimental physics and not any in theoretical science. I mean, nobody looked at the quantum mechanical laws of Schrodinger and said, let's build a transistor. These were some guys fritzing around in a garage, and if you look at the original transistor, it's chewing gum, it's a coat hanger, it's a crystal. It's pretty wacky stuff. And nobody looked at the Schrodinger equation to solve it.
Boy, do I have a different impression of this. I mean, my life is so determined in part by the synthesis that had occurred by the mid-'70s. And if it weren't for Jim Simons and C.N. Yang at the State University of New York at Stony Brook figuring this out, my life would be completely different. I think that, so many things hinged on the fact that the Glashow, Weinberg, Salam model and speaking of Ed Hooft, showing the renormalizability of these gauge theories and the way in which all of this stuff conspired is incredibly important for allowing other fields to progress, in particular differential geometry and topology and this beautiful renaissance. So I think it actually was super important that this stuff should have been discovered earlier. It would have been nicer if when Yang and Mills, what was that, 1954, 53, something like that, came out with their theory, that if they had understood it to be geometric, I really think it's a tragedy that we don't have Cian Yang on our lips. Whenever I hear people say that Steven Weinberg or Ed Witten is the world's greatest living theoretical physicist, I always say, I'm waiting for the day when another name is added to that, and Cian Yang is my favorite.
I'm going to try to get him on the show.
Godspeed. But look, in part, I think it actually really does matter. The problem is that it's a story to which almost no one is paying attention. And if we're going to get off this planet, we are going to need a fundamental theory. You're going to want those theorists, in Jack Nicholson's wall. You're going to want those theorists on that wall.
Actually, the wall is at Stony Brook, and you and I are going to go in with a chisel one night and chisel some equations on the wall. Okay, we have a few minutes left. Any other questions? I want to scan quickly through, make sure people got their money's worth. But while I'm doing that, Eric, I want to ask you a question that I asked. This is from Allison Walker. Quick one. Thanks. What's written on top of a purple heart? Okay, I don't know what that means, but Allison is a good friend of the show. Thank you. I want to know if you subscribe to this notion of the ethical will. And I asked this of all my guests. I asked this of Jim Simons to Jan Levin to almost anybody that's come on the podcast. And I want to know, in your opinion, if you were to leave a legacy, not of material goods, but an ethical will, a will of wisdom, a will of experience based on your experience, that would be not only for your biological children and grandchildren, may there be many, but also for your ideological children, of which there are already. You realize you make a huge impact on the world, Eric, and what you say people listen to and pay to hear, and I get it for free, and I should reimburse you someday. I'll pay you that 3 Bitcoins that I promised you 20 years ago. But anyway, what would you leave in your ethical will? And then we'll finish up with a question from our friend Tyler.
I mean, I think what I'd leave is, look, the only thing that I've ever done in my life that has the ability, even potentially, to compete for the attention of people 1,000 years from now would be geometric unity. And it's quite possible that it's just wrong. I don't think it is. I'm betting heavily on it. That would probably be the first thing. And what that thing is it's about hope. It's about all sorts of crazy human motivations. It was an incredibly self-destructive undertaking. And I worry about communicating it to my son, which is, do I want to tell you to try to do something at all against all odds? Money's no object. Health is no object. I mean, my guess is that I was probably overweight for a large number of years, in part because I had stopped thinking of myself as a member of this planet, which is probably incredibly unhealthy and delusional.
Wait, you feel like that was intentional? I mean, for me, I'm addicted to food. I eat too much because
No, of course, but my point is that I sort of checked out. And, I mean, when I talk about this twin nuclei problem, I'm not kidding around. I really do believe we're all wearing face masks potentially because of something that might have come out of the Wuhan Institute of Virology. And the thing that gives me the most confidence is just how certain I'm not supposed to say that YouTube and the federal government is, So I don't know whether we're going to have a problem with nuclear weapons. I don't know whether we're going to have a problem with these viruses, but we have to get out of here because we've outgrown this planet and we're too powerful and we're not smart enough. Our politics is a mess and we've got to spread out because we can't have one correlated experiment. So the core of my ethical will is that. Now, I speak a lot on a lot of different programs. And one of the things that I feel very confident of is that if my children ever choose to pay attention to me again, there will be a corpus of audio and video that indicate what did I think? What did I think about politics? What did I think about decency? What did I think about how we treated homosexuals years ago when we wouldn't allow them to marry? I think I've opined on so many things that if were I to die this instant, there would be a huge record of my thinking.
And I think, too, as I've told you, what if you stumbled upon something from the shtetls of Eastern Europe and it said, great-grandma Nechama Weinstein, and you found this book and they said it's going to be 100 Bitcoin, you would pay it. And so I want you to think about your children's children's children and think about putting something in writing, because we have books from Galileo. We have books from Einstein.
Brian, you're lying. You've been trying to get me to write a book for ages, and now you're pressuring me and you're negging me on international television.
I'm just saying, people are out there. Okay, people are asking, what is Lex Fridman like, and what is his uniqueness in the role of the podcasting world? And then we
Lex
have one
Fridman
comment
is
from
brilliant, gorgeous, and ladies, he's single.
And Tyler is asking a question. I'm trying to find Tyler Goldstein. Goldstein has a question, and I want to get to that. It's Allison. No.
You want to go rapid fire?
Let's do rapid fire. Yeah, okay. Vulnerability is kind of, we realize it's space time. Let me see here. You need
Take the energy up, Brian.
What's that?
Take the energy up.
Okay.
Fast.
Okay. What do you think about Gödel? Gödel's incompleteness theorem.
I never wear them. No, sorry. I think that it's fabulously interesting, but I think that we tend to do it too much as a gee whiz. I'm sure that there's a formal way of saying it that sounds more like there's certain things that are true for good reasons. There's certain other things that happen to be true, but they don't have a good reason, and that means you can't necessarily prove that they're true inside of the system. I would love to hear somebody say it that way. I've never heard it properly done by a logician, so it has too much of a gee whiz thing.
All right, Tyler
Next.
Goldstein is asking, Eric, if I remember correctly, I think you said on a podcast, the next scientific dynamos may be religious people. Do you think these people would have to find unorthodox paths presenting their work outside of academia?
Ish. The problem is that right now we're having a huge problem with academics becoming too self-destructive. In a weird way, you pay a cost for being religious, that you often believe something on faith. There are religious scientists who are able to take their faith and their science and separate them so that they do good scientific work, but they use their convictions to potentially martyr themselves and put themselves in low probability of success situations. That's what that was a reference to, and I happen to know some biologists who don't agree with Darwinian theory, but if there were problems in the neo-Darwinian synthesis, let's say, you might find that the people like Richard Dawkins would be wanting to say there are no problems in that synthesis, and you might be dependent on somebody, even assuming there's no God and everything is completely materialistic. The challenge might have to come from a religious person who would destroy their career going up against neo-Darwinian ideas, but then that person might actually point out, that thing you said about random mutations, that can't possibly be the principal engine of evolution, because the search space doesn't conform even over long periods of time with many bacteria exploring genetic variants of certain primary sequences. So that kind of self-destructive energy comes from religions. One of the reasons why religions have been very difficult to get rid of by atheists, because in fact, when people have that kind of faith and conviction, they start thinking beyond themselves, and that's a very potent force.
Is there anyone you're afraid to debate?
Sure.
Care to name them? Care to name her?
What? Care to name her? Let me think. Well, look, there's one person who absolutely terrifies me intellectually, and that's Ed Whitman.
All right, we're going to try to arrange that, as you know. That's my white whale, my white Witten whale. Is there any position in physics that you think is being promoted purely for hype? In other words, wormholes, time warps, the simulation hypothesis. I mean, these are all things that I think of as hype. What do you think is the biggest hype?
I think the whole gee whizification of things that are real, like Boltzmann brains, the multiverse. It's like we're always interested in time travel, going backwards, and wormholes to parallel universes. And you've got to know when to quit and how to do science fiction right. I feel like what we've done is we've taken a small number of topics with maximum sex appeal, we've sexed them up, and we've forgotten how many gorgeous, beautiful ideas. I've been I'll be honest. I've been talking about this for a while, and then I saw Sean Carroll do a series called "The Biggest Ideas in the Universe." Now, Sean and I have sort of a weird relationship. We're cordial when we meet each other, but there has been some tension in it. Yeah. And I wonder whether he had actually heard me on programs like Rogan talking about the hop vibration and things like that, saying, why is it that we're not extolling all the cool things that we do? Why do we keep hitting these same topics? Because I think he had hit the multiverse, the Boltzmann brain, that kind of stuff pretty hard. to be generous to Sean, if I can, I thought he did a beautiful job over a very large number of very difficult topics, some of which I had myself, been experimenting with talking about. So I think we need to stimulate some of our science communicators to showing more of what it is that we actually do, because it's so effing cool that it's crazy that we keep it locked away while we bullshit about things that are of marginal importance.
Okay, rapid fire questions. James Thompson, is the universe expanding or are atoms shrinking? Yes or no?
Don't love the question.
Should my kids go to college or try to find something outside the college university system?
I think we should try to send our children to graduate school and skip college. We should try to find Lambda school-like opportunities to cut down the expense. And we should partition the subjects that are super serious as a heart attack subjects, and get them away from the subjects in which a penchant for bullshitting and fashion tends to take over the subject. We do some incredibly important, difficult things at universities, and we do a lot of things that shouldn't be done at universities, and it's time to divorce them one from the other. So I think it would probably be good to start doing away with the current college model and try to figure out what's next.
Do you think that Trump will leave office?
I do.
Do you think that he has a secret file on the incoming occupant of the Oval Office?
I don't even care. I think that the key problem, my guess as to what's going on is that the Democratic forces and the establishment forces have oversold just how little fraud there is, and the Republican and Trump-like forces have oversold how much there is. And so the weird part about it is that people are also kind of lying about the truth, and that's causing us to get very confused. It's somewhat akin to the question of, did HIV cause AIDS? They jumped the gun on it, but it was also true. So if you were using a jump the gun detector, you decided that was BS. On the other hand, if you used an underlying thing, you would say, well, that wasn't originally true, but it turned out to be true. My guess is that there was way too much pressure to put Biden in office, but that Biden actually did win the election, and that's going to be very difficult for a lot of the Trump supporters.
You think he's going to come back in 2024?
Well, as a 78-year-old guy, I think he's doing a lot of damage to himself. If Trump walks out of the Oval Office babbling incoherently about so unfair, without putting up a serious conspiracy theory, I mean, at this point, I want to see a serious conspiracy theory or concede the election. What is your conspiracy? If you have the data, if you have the allegations, I want to know them in terms that I can really understand. And I understand it might take you 5 years. We might find out the deep state through the election 5 years from now. We don't have 5 years to wait. So if you don't have it now, and if you don't have it for the courts, you're going to have to leave office.
Would you rather have a Nobel Prize or be president for 2 terms, guaranteed?
I would definitely not want to be the president of the United States.
Do you think it's dangerous if a Jew would become president? Would that be a good thing for the world, a bad thing for the world? What do you think?
I think it depends on the Jew.
Okay. Let's see here. Someone wants to hear a serenade on the way out. We'll give that in a minute. If you had a time capsule that you knew would last 1 billion years, like a monolith in 2001: A Space Odyssey, I may have asked you this, but I may not have. What would you put on that monolith, in that monolith, for some species in the future to discover when they're ready to discover it?
There's a wall that we are going to visit in the State University of Stony Brook, State University of New York at Stony Brook.
Where I was born.
The whole point is to get that wall right. There's a bunch of stuff on that wall that shouldn't be on it, so we have to deface the wall to remove the things that are extraneous. We have to improve the things that aren't in their proper form. But that wall is an unbelievable mecca, and all you young kids, if you want to know what that monolith should look like, go to the Simon Center for Physics and Geometry and take a look at that gorgeous Indiana limestone and the beauty of what is written into that, and make your assignment for your life that you will understand what is carved onto that wall by the time you hit your 30s.
Would you rather shrink to the size of a DNA molecule or be able to visit the interior of a black hole inside the event horizon?
I was just hoping to get some sleep this week.
Well, your Tuesday's canceled.
Okay. Neither.
Okay, neither one. Okay.
I'm a mesoscale kind of a guy.
Would you rather go back in time 500 years or forward in time 500 years?
There's a particular weekend I would like to visit during my junior year of high school, but we don't get do-overs.
All right. Okay, Eric. Someone's asking, will you serenade us out with something mind-blowingly amazing from the world of geometric unity underneath that Yiddish cup of hair? Will you serenade us on the guitar as you take us out? Maybe the Shalom Aleichem or something like that for the evening that's about to approach. That's awesome. Thank you so much, Eric. We'll do this again. Maybe we'll make it regular. I want to thank the audience, all you super chatters, regular chatters. Please subscribe to Eric's channel on iTunes.
No, Brian's channel.
All right, fine. If you must, please subscribe. We've got great guests. Jared Tooth, hopefully will come on. Cian Yang. We have Qumran Vafa next week. And we will update you all. Look for Shelly Glashow, others to come. Eric.
Can I just say a few words that you can't say?
Sure.
People need to understand that Brian is getting some of the best guests in the world. They're not polished. They're not necessarily professional podcast guests. And I think that it's just really important to recognize that if you're used to banter, excitement, joking, guitar, you're not necessarily going to get that on this channel. But what I want to say that he can't say is that he's crushing it with respect to who he's able to get. If you're able to listen to Sheldon Glashow, who paid me $1 that he owed me for 27 years.
That's right.
I want to bet with him. Shelly was a prince of a guy to give me the $1 after 27 years, finally conceding the bet. Qumran Vafa, Lenny Susskind, Noam Chomsky, I am clearly not qualified to sweep the floor of this channel. Habituate yourself, if you can, to understanding that these are some of the most important minds that you're going to listen to. And if they're not polished and if they don't make sense, I would start to pick up an acquired taste, because the only podcast that's getting comparable guests is Graham Farmello's podcast, which is barely a podcast at all. And this is really an honor to get to appear here in the company of such incredibly serious people. So keep trying to figure out what we're doing here, and we'll figure out serious scientific podcast.
And I want to thank you for talking me down from the ledge on many occasions as I get my footing. And
not true.
No, it is. You actually do a great deal of good for me, for my family. I love you. We love you. Shabbat Shalom. Everybody out there, thank you so much. And we'll do this again. And stay tuned for more wonderful content as we go into the impossible. Signing off, your fearful host, Brian Keating, and his good buddy, Eric Weinstein. Good night.
Shabbat Shalom, everyone.
Shabbat Shalom.